Good evening, everybody. Hello, hello. Thank you for stopping by. It is not 1:30 in the morning this evening. Can I get an amen? So, let's see. Anything that I wanted to mention before we jump into things here? Can't really think of anything. Let's just dive in. All right, so here's our first day breaking out of free code camp. We're still going to be in. We're still going to be doing free code camp, but we're just going to be doing like extracurricular stuff, i.e. Corey Schaefer's YouTube or Corey Schaefer's playlist on YouTube, the Python Programming for Beginners playlist. I don't know how long this playlist is. It says watch the playlist over the day 3 and 4. So, yeah, I'm not really sure what to expect here. But before we do that, we're going to get into our next free code camp videos. We don't have any exercise videos on this one, so it should be relatively easy. Yeah, let's get into it. Sorry, I was reading this here, but let's take another step towards becoming a software engineer.
Hello and welcome to Chapter 3, Conditional Execution. In conditional execution, we meet the if statement. The if statement is where Python can go one way or another way, and it's the beginning of sort of our way of making Python make decisions for us. Sequential code, we just do some things. Sometimes that's useful, but now we can have our code check something and then make a decision based on that thing. So the conditional steps in Python are pretty straightforward. The keyword that we're going to use is the if statement. And so if is a reserved word. And the if statement has as part of it a question that it asks. And this is asking if x is less than 10. And the colon is the end of the if statement. And then we begin an indented block of text. And the way this works in this particular thing is this line is the conditional line. If the question is true, the line executes. And if the question is false, the line is skipped. And you can think of it the way this is, right? X is 5, ask a question. Is it 10 or not? These questions do not harm the value of x. If it is, then we run this code, and then we sort of rejoin here, and then we test this next if. And if that's true, we do this code, and then we do there. But in this case, it's going to be false because x is not less than 20, and so it just continues down here. So if we look at how this works, it runs this line, then it sees this question, it skips that line. So this line does not run, and so smaller prints out and fini prints out. Okay? And so that's the basic idea of an if statement. And the indentation, when we are done with an if statement, we de-indent back, and there's this little block. This is one sort of if statement, and this is...
Okay, I'm sorry. Did y'all just hear that, like, the white noise just cut off immediately when he brought up this screen? If I back it up.
Statement. And the indentation, when we are done with an if statement, we de-indent back, and there's this little block. This is one sort of if statement, and this is another if statement.
Works with
and
me.
These are the two conditional lines that either run or they don't run, depending on the question, the answer to that question. So we have a number of different comparison operators that we can use
and it's back.
to ask these true-false questions that say, is this true? So again, we're kind of limited to the keys that were on computer keyboards in 1940s and 1950s, less than or equal to.
I'm going to read this Boolean stuff here. Bear with me. All Boolean expressions are yes or no. Boolean expressions ask a question, produce a yes or no result, which we use to control program flow. Boolean expressions using comparison operators evaluate to true, false, or yes, no. Comparison operator is important. Comparison operators look at variables but do not change the variables. Okay.
So we didn't have fancy math characters, so we just concatenated less than and equal to be less than or equal to. This double equals is the asking, is this equal to? And so that's a little tricky. The equal sign is that assignment operator. If I was building a language today from scratch, I would probably make assignment be arrow and the equals question to have an equals. Or I might say, somewhere I would say question equals. But I'm not building this language, so it's not up to me. So this is the question. Double equals is asking the question is equal to. Greater than or equal, greater than, and not equal. So this is the exclamation point is sort of like not equal. So that's sort of not equal. So that's how we do not equal. So if we take a look at some of these in some examples, all of these are going to be true because of the way x is set. If x is equal, these are going to be equal.
I want to listen to the not equal.
Greater than and not equal, equal to. Greater than or equal, greater than, and not equal. So this is the exclamation point is sort of like not equal. So that's sort of not equal. So that's how we do not equal. So if we take a look at some of these in some examples, all of these are going to be true because of the way x is set. If x is equal to 5, that's the question version. That's true or false. It'll execute that. If x is greater than 4, it's going to execute that. If x is greater than or equal to 5, it's going to execute that. Here's kind of a shorthand where if there's only one line in this block, you can kind of pull it up right on the same line after the equals. If x is less than 6, which it is, true, execute that. Then if x is less than or equal to 5, do that. And if x is not equal to 6, do that. Now, like I said, all these questions have been carefully constructed so that they're true, just to kind of show you the syntax of those comparison operators. Now, you don't just have to have a single line of text in the indented block. And this will be something you're going to get used to. So if we indent more than one line, then the conditional code is actually these 3 lines. So the idea is you have an if statement, you come in, you do an indent, and as long as you stay indented, you stay in that if block. If it's false, it just skips all of those. So the way this is going to execute, x is 5, print before 5, is x equal 5? That's the question mark, and that's true. So it's going to run all these, and then come back, and then continue on in the de-indent. So all this stuff is...
Okay. Hold on a second. So x equals 5, print before 5, so that's that bit. If x is equal to 5... print is 5, so that's the first part. Is still 5, which falls right after it, and then third 5. Print afterwards 5. So that's, I mean, pretty straightforward.
Is running, right? And then it says x equals 6. Well, that was false, so that skips all of them. So,
wait, what?
So none of, and then it says x equals 6. Well, that was false.
Oh, my bad. Okay, no, yeah. Because it defined 5 up here, or excuse me, defined 6. X equals 5. Oh, 6. It defined x as 5. Goodness, forgive me. Then it says if x is equal to 6, which it is not because it is 5, then but it skips all that, is what he was saying.
So that skips all of them. So none of these lines of code run. So these actually don't run, and it says afterwards 6. So that's a mistake. Those don't run right there.
I get that.
Okay?
I understand.
X does not equal 6. Okay?
Okay.
So indentation is an essential part of Python. We use indentation in lots of programming languages, often to kind of demarcate blocks, to show where blocks start and stop. But in Python, it's syntactically correct. You can make an error if your indentation is wrong. After an if, you must indent. And you maintain the indent as long as you want to be in that same if block. And then when you're done with the if block, after an if, you must indent. And you maintain the indent as long as you want to be in that same if block. And then when you're done with the if block, you reduce the indent. In this rule of indenting,
what do you say about
but
mistake?
in Python, it's syntactically correct.
Mistake?
You can make an error if your indentation is wrong. After an if, you must indent. And you maintain the indent as long as you want to be in that same if block. And then when you're done with the if block, you reduce the indent. In this rule of indenting, comment lines and blank lines are completely ignored. So we're going to tend to like put 4 spaces. 4 spaces ends up being the normal thing that we do, and you'll see all the code that I write has 4 spaces for each indent. If I go in twice, I use 8 spaces. And we have this instinct of wanting to hit the tab key to move in 4 spaces. Now the problem is that it might look the same on your screen. A tab and 4 spaces might line up the same place depending on how tabs are set. But Python can get confused by that. So we tend to avoid using actual tabs in files. And so most programming text editors, like if you're using Notepad or Text Wrangler, there's a place to set the tabs to say don't put tabs in this document, but every time you hit a tab, move over 4 spaces. And so you hit a tab, but it's like space, 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 space. Now the nice thing about Atom, and this is the text editor we tend to recommend in this class, because it works on Windows, Linux, and Mac, but also because it automatically sets this up. As soon as you save your file with a .py extension, you can sort of hit the tab key with impunity, and everything works perfectly. But the key thing here is that Python insists that you get this right, and if you don't get this right, you're going to get indentation errors, and they're just another syntax error. So if you're using something like Text Wrangler or Notepad, hunt around in the preferences and you'll find something about expanding tabs, or maybe how many spaces each tab stop is supposed to be. And so you check these, and what this really is doing is telling your text editor never put an actual tab in the document, but somehow simulate tab stops using spaces. And so here is a bit of code. It's got a nested block, but it gives you this sense that you have to be very explicit when you're reading Python code of whether the indent is the same between 2 lines, the same, increased or decreased. And so every time you increase it, you mean something, and every time you decrease it, you mean something, and literally if it stays the same, you mean something as well. And so if we take a look at this, here we have a line, and the next line has the same indent. This is an if with a colon at the end, so we have to increase the indent, and now we're maintaining it. Okay, so these 2 lines are part of that if, but now we have de-indented. So whether you choose to de-indent this word or whatever, where you do this de-indent affects the scope of how far this if statement lasts, right? It lasts up to, but not including, the line that's de-indented to the same level as the if. Okay, so this is a de-indent. Now we have a blank line, which doesn't matter, and we maintain it. Now we have a for, which we'll learn about in the next chapter, which is a looping structure. Let's do a for runs this 5 times. It has a colon, and it also expects an indented block. Now we have what's called a nested block, where we have an if and a colon, and we go into some more. So this is like 2 indents, right? So these are 1 indent, and these are 2 indents. And so this is a block within a block. And then we de-indent, so that means this print is not part of the if statement, but is still part of the for statement. And then we de-indent again, and then that means this print is sort of on the same level as that for statement. So if you start thinking about this, you want to be able to start thinking that these blocks are the start of the block with the colon line up to but not including this line that's been de-indented. So the for goes this far, right? The for goes up to but not including the line that's de-indented. The if goes up to but not including the line that's de-indented.
Makes sense.
So as you do this, you'll sort of mentally start drawing these blocks, and pretty soon you will start constructing them as blocks. And it takes a while, but doesn't take forever. But in Python, unlike other languages, you have this is very important, and it matters, and you can have syntax errors if you get it wrong, because you're really communicating the shape and structure of your code using these indents and de-indents. We already saw a nested indent. This is a nested if, so you can put an if within an if, and you can go as far deep as you want to go, like Russian dolls. And so here we have x equals 42. If it's 1, we indent 1, and then with this next thing we do, these are at the same level of indent, but now we see an if, and it has to indent further. So this is like 2 in, 8 spaces, and then we de-indent back. Actually, we de-indent back 2. And so if you watch this and you take a look at how this works, it runs to here. Oops. Back up. Comes in here. The answer is yes, x is greater than 1. Prints this. Is x less than 100? Well, it's 42, so the answer is yes. So it runs this, and then it kind of continues.
Okay, I want to look at this here. If x is greater than 1, which it is, it would print more than 1, and then it would come down to, is it less than 100, which it also is, it would say less than 100, which it would then lead to then printing all done.
Continues back to there. And you can also think of drawing boxes.
Sometimes I just got to like stop and just kind of take it in, you know what I mean?
Boxes around this. This is one if box, and then within that if box there is another if box. And again, it's the indent block up to but not including where the de-indent happens. And this here is like 2 backwards de-indents. So it ends 2 blocks. So 2 blocks are ended by where we place this. We could move this in, or we could move this out. We could have it all the way into here, we could have it to here, or here. And where we put that line depends on how the ends of these blocks are going to work out. So one form of that's a 1-branch if that we just saw, but then you can also have what's called a 2-branch if. And the basic idea of a 2-branch if is that you're going to come in, you're going to ask a question, and you're going to go one direction if it's yes, and another direction if it's no. We call this an if then else. It's kind of like a fork in the road. And the way to think about it is, depending on the output of this question, we're going to pick 1 or 2 of these, but if we pick one, the other one's never going to happen. So it's like an either or. We're either going to go one way, or we're going to go the other way, but there is no path where we somehow go boot through both of them. That doesn't happen. And the syntax that we use for this is what we call the if then else. And so the first part is normal if with an indent, and then we de-indent, and then this is another reserved word, else, with a colon, and then we re-indent. And so this is really end up being part of a whole block here, and the else is the part, this is the part that runs if it's false, and this is the part that runs if it's true. The first branch of the if, the first indented block is what runs if it's true, and the second indented block is the one that runs if it's false. And so here we go, just if x is greater than 2, in this case it's yes, we're going to print bigger, and then we're going to be all done. And so we do 1, and so this one did run, and this one did not run. So basically with an if then else, one of the 2 branches is going to run, but there's no case in which both branches run. And again, you sort of draw these blocks around these things mentally, and in this one you sort of take from the if, not the else is really part of the block, up to but not including that print, which is back indented, de-indented back to the same level as the if statement. Okay? This Python is actually one of the more elegant languages, even though after a while this indenting, and when you get too far in, it gets a little bit complex. But this is a good way to visualize this with these indents. Coming up next, we're going to talk about some more complex conditional structures.
Okay, so I was going to say something. Shoot. Can't remember. Oh, yes, that's what I remembered. When it comes to those if else's, you know what I mean, those what do you say, functions? The idea when I first saw this, the idea that came to me was like you could make like choose your own adventure stuff by doing that, because it's like if character goes down the left path, you see a dragon, else go down the right path, and you see a light at the end of the tunnel. I don't know, you know what I mean? And so, and then from there you could just branch more and branch more and branch more, and it could just, you know, you could come up with a whole story that way. I don't know. I just thought that was kind of cool. But let's just, for the sake of messing around, I'm a tactile learner. I learn the best by just kind of getting in and doing something on my own, getting my hands dirty, as it were. If, hold on, let's define something. X equals 45. If X is greater than 40, colon, print bigger than I don't know, 40. Else, I hope I'm doing that right. Else, whoops, print smaller than 40. Wait. Right. You know, that's fine. The whole tab thing, I don't really need to worry about. Tabbing seems to work okay for me in here. Maybe it is the 1, 2, 3, 4. Looks like it is, actually. I know he said that it looks like it might line up, but you can still get issues. I haven't had any within Visual Studio Code. So, print, we're going to say print done. Just so we know, right? All right, and we're just going to do this in here. I'm not going to worry about command prompt. Cool. It worked. Right? Can I make this? Hold on. Let me make this even bigger for you guys. Hold on a second. Where did I go yesterday? Font. Here we go. If only I can make this bigger. Can I make this bigger? I don't think I can. Sorry. Cool, but yeah, that worked. Because 45 is obviously bigger than 40, bigger than 40. Done. Skip the whole else bit. So if we do 35, smaller than 40. Done. Okay, so let's do this bit. Which code is indented correctly to print? Yes. If x equals 0 and y equals 10. I feel like it might be this one, but I'm not 100% sure because after the if, you need it to be indented, right? But then there's another if. Oh, man. I'm not sure. Yeah. Sweet. Cool. Moving on. Oh, we got exercises. Okay. Let's get those expanded. Are they big? Ugh.
Hello, welcome.
Okay. That's all right. That's all right. We're here.
So welcome back. Let's talk
We're
a little
here.
bit more about some more complex conditional statements that sort of build on this concept of if and if then else. The first thing we're going to look at is the multi-way branch. And so the idea is it's kind of like the if then else where you're going to pick one of two, but now we can pick one of three or one of four or one of five. And it introduces a new concept called the elif. The elif is another reserved word inside Python. And the way it works is it's probably best to look at this here where it checks the first one, and if it's a true, then it runs that, and then it's done. It doesn't check them all. It's not like it sees that there are two logical conditions. It actually checks them, the first one, and how you order these matters, as we'll see in a bit. And so if the first one is true, it runs. If the first one is false and the second one is true, it runs this one and it's done. And if the neither of them are true, it falls through, and there's an else clause that is otherwise, and it runs that. So basically, it's either going to run one and then skip the other two, or it is going to
work its way through.
Skip one, skip two, and then run this one. But it only runs in this case one of them. But the important thing is it checks these questions in order, and it doesn't check the second question until it finds that the first. It doesn't check the second question until it knows the first question is false. So if the first question is true, you're done. You're done, and you're done with this. You're done with the whole block at that point. So only one of these three is going to execute in that block. So here's sort of some examples of this. If we, for example, have x equals 0, it's going to come down here. X is less than true. That's true. So it runs this code, and then it skips down to that. And so it's like this. Runs that code and then skips to the end. Okay. On the other hand, if it's 5, then this is false, and it skips that, and it checks this. This is true. It runs this code, and then it's done, skips to the end. It goes like false, true, run, end. And then if x is like 20, for example, it runs, false, false, run the else clause, and you're done. So skip,
makes sense.
Else, run that code, and you're done. So in this case, we ran that, and we didn't run that, and we didn't run that. Again, one of them's going to run. They're checked in order. These questions are checked in order, not out of order. It doesn't look ahead. It just checks in the order that you wrote it. You're the one that wrote that order. And so there's a couple of variations on this multi-way. You can have no else. You can have no else, as in this case, and this just means that it might not run any of them. In this case, x is 5, so it's not less than 2, but then it runs this one. But if x was like 50, for example, if x was 50, then this would be false, then it would skip, and this would still be false, and it would skip, and neither of these two would run. So if you don't have an else, you're not guaranteed that one of them is going to run, because else is like the catch-all. If the other ones are all false, then the else is the one that runs. Similarly, you can have many elifs, but this is where it's really important for you to make sure you know what order they're being taken in. So I've got, this. If this is true, it runs. It goes all the way to the bottom. If this was, if it's false, 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 true, it runs this one and it's done. If, on the other hand, it looks at it as false, oops, go back. If it runs false, 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 they're all false, then it runs the else. Right? This one has an else. This one didn't have an else. They don't have to have them. The key is you can have more than one of these elifs. Okay? So I got a couple little things. I'll let you pause right now and look at, the question is, are there, looking at the 3 lines or 4 lines of code, x equals something. Are there lines of code that will never execute regardless of the value for x? And I'll let you pause and think about it, and then I'll explain it to you.
Okay. So, if x is greater than 2, print below 2. If x is greater than or equal to 2, print 2 or more. Else print something else. If x is less than 2, print below 2. If it's greater than or equal to 2, print 2 or more. The else will never print. Because it's either going to be greater than, or excuse me, it's either going to be less than 2 or greater than or equal to 2. There's no situation that would call for the else. That's that one. Little x is less than 2. Print below 2. If x is less than 20. Okay, I know this one because I've seen this before, so I'll just let you guys know. It's this. This won't run. Because if it's less than 2, it'll print below 2. If it's less than 20, it'll print below 20. But if this runs as like a true statement, which it would, like, I mean, if it printed below 20, it would be true. It would just skip over 10. Because if it's less than... Wait. I mean, I'm trying to understand, because I know that's the, like, will else print? If x is less than 2, print below 2 if it's less than. So if it's basically greater than 20. I don't know if the else will print. Because if x is less than 2, print below 2. If x is less than 20. Wait. If it's less than 2, it'll definitely be less than 20. And 10. So like if it's 5, right? It won't be below 2. It will be below 10. So that'll run. So else will print. If it's like 30, because it's greater, it's not less than 2, it's not less than 20, and not less than 10. But there's no situation in which the 20 and the 10 will run? No. Just the 10. Because it could be like I said, like 5.
Okay. Hopefully you paused and thought about it as long as you like, but so let me now explain it to you. So we come in here, and if x is less than or equal to 2, it's going to run this first thing, and if x is greater than or equal to 2, it's going to run this, and if neither of those are true, then it's going to run this. Well, the weird thing is, all numbers are either less than 2 or greater than or equal to 2. I carefully constructed this to the point where it would never run this line of code. It is either going to run this one or run that one, but it's not going to ever run this one. So that was kind of like a weird dysfunctional one that I constructed. This other one is a little different. If x is less than 2, we do this. If x is less than 20, we do that. If x is less than 10, we do that. And if none of those are true, we do that. Well, the problem here is between these two lines. The problem is if something's less than 10, like 6 for example, it's also less than 20. So even though there might be values for which this is true, those also are going to have this true. So for something like 6, it's going to run here, and it's not even going to look at this. That's the point. It doesn't even look at this. And so I mean, I could have made this more sensible if I'd have moved this little block of code up to there. So this is where the order in which you choose your questions.
With a number like 6.
The way you put these LFs together matters because it doesn't look at all of them. It only looks as long as it can. As long as it sees falses, then it keeps on going to the next one. But as soon as it doesn't see a false, it doesn't continue.
I get it.
So the last conditional structure we'll talk about is the try and except structure. And if you know any other languages like C++ or Java or JavaScript, you're like, whoa, that's kind of an advanced concept. But it turns out in Python, because of Python's propensity to throw tracebacks in situations where you kind of would like to recover, it turns out you kind of have to use it a little more and a little earlier in your programming skill. So the problem is what if there is a line of code and you absolutely know it's going to make a traceback, it's going to blow up, but you don't want to blow up. I mean, I don't want to have code blow up. If you're using my autograder and you see a traceback in my autograder, that's kind of like, I consider that a failure. I could put an error like, hey, you entered blank data or you didn't enter a number, but a traceback, that just seems like I'm too lazy as a programmer. So we as programmers are supposed to anticipate parts of our code that are going to blow up potentially based on perhaps the user's input and then do something about it. And that's what the try and except are for. It's you take this little dangerous piece of code that might break and might blow up, and you surround it with a try and says this might blow up, and if it fails, run this code down here. Okay, so that's the try, and if you get an exception, the except is kind of like if you get an exception. And the problem is if you are running code, here's a little bit of code, we put hello Bob in and we convert it to an integer, and we know from past experience that this blows up. Right? You can't take hello Bob and convert it to an integer. It's just going to blow up. The problem is, and you know, here we are. It says, oh, you blew up on line 2. That's great. And I'm not very happy with hello Bob and whatever. But the important thing is your program stops. These other lines, they don't, oops, these other lines, they don't exist. Right? It doesn't go any further. Remember the traceback is Python is really confused and I don't know what to do next. So Python is just going to be conservative and stop. So Python stops and your program stops. No matter how much error checking you put down here, it doesn't matter because it's gone. It's all gone. And like I said, we take this kind of personally because the code that you write is like you being put into the computer, giving it instructions. And if the code blows up, well, that sort of wipes you out. You're not in the game anymore. You're not able to do anything. So we want to be able to, especially in these situations where we can anticipate that an error that might happen in the normal course of your program's execution might be something that you want to compensate for. And that's what the try and except does. So here's a bit of code for the try and except. And we just have 2 little bits of straight line code. And so we put a string in here that's hello Bob, and then we're going to convert it to an integer. This is the dangerous code. This code in this case with hello Bob is going to do a traceback. And so we say try, and then we indent the dangerous code, and then we add this little except bit. If it works, the except is ignored. If this blows up, it runs the except. So in this code, it's going to come in, it's going to try this. This is going to blow up, but instead of giving a traceback, it's going to say, "Ooh, I've got an available except. I'm going to run this except code, and then I'm going to continue on." And so that prints out first -1. So because we set this variable ister to -1, like a little flag telling us that something went wrong. And then we keep on going, and now we have put in 1, 2, 3, the digits 123, the digits 1, 2, 3, and now it's going to work, but we still have it in a try block, and then this one works, it does not blow up, and then it ignores the except block. So the except block is only triggered when something goes wrong in the code. It is.
So, I'm looking at this bit. str equals 1, 2, 3. I get this part. First -1, I get that part. So it is -1. Ister is -1. So try turning Ister into an integer, which is already... Wait, turn Aster. Oh, this is a totally separate thing, might be. So turn aster into an integer, which already is, if I'm not mistaken. No, I don't know that it already is, but it's like turning it into one, which is fine because it's numbers, and so it ignores the except.
Is ignored
And then,
if something doesn't go wrong.
right, so nothing went wrong. And print second eister, which is 1, 2, 3. Yeah.
So it's like you bought an insurance policy on this line of code, and when things go wrong, your accept block springs into action and does whatever it is that you want it to do in the case of an error. Okay, so that's a pretty useful thing. You got to be a little bit careful that you don't overuse it, because if you put more than one line inside the try part, and one of the lines blows up, it doesn't come back to the try block. And so in this one here, we have kind of a simple, silly one where we set the string. We're worried about some stuff. Well, the print statement's never going to blow up, so it's a bad idea to put it in try except anyways. Then we do this conversion, and that's the dangerous part. And in this one, it's going to blow up. And so then it's going to go to the accept block and then run the accept block and then continue. What it doesn't do is somehow go back and finish this. So these lines are gone. So if you look at it like this works. The try starts. Hello. This blows up. It goes to the accept. It runs the accept, and it continues on. Never runs that code. So it's not like you took out an insurance on the whole block. Any of those lines can blow up in the block, but whichever line blows up, that is the last line that's executing in that block.
Mm-hmm.
Okay? So you tend to want, in this particular example, you would probably, the print statement would go out there, and this print statement would come down here, and you would only put in your try block the single line of code that you think might blow up, because you kind of know print statements aren't going to blow up. So this is an example that's a more common real-world example where the user is going to type some data. And it's users that get us in trouble. So our program starts by asking the user to enter a number, and we know that this could be dangerous. So we're going to do it. We're going to put the conversion from string to integer in a try block, and we're going to set -1 if that's a failure. And then if it's greater than 0, we'll say nice work, and if it's less than 0, well, not a number. So first time we run this program, out comes enter a number. We type in 42, which is a string. That 42 goes back into roster, runs in here. This runs. It's fine. That becomes a 42 number, so we skip the except block, and ival is greater than 0. We print out nice work, and we skip the else. Okay? So it says nice work. On the other hand, if we run it again, this time, the input says enter a number, and we're silly. We enter the word 42, but in words, 40, F-O-U-R-T-Y. So that's a string, and that goes into roster. And then the execution continues. We run in here, and now this is going to blow up. That's going to blow up. Normally, we would see a traceback right there. There'd be a traceback. But we're not going to, because we put this calculation in a try and accept block. It's going to immediately run the accept block, set ival to -1, continue on with the program. See, you are not blown up at this point. And if ival is greater than 0, well, it's -1, so we're going to hit the else clause and print out not a number. So we've done error detection. The user set something that caused a line of our code to kind of blow up, but we put that line in a try and accept block, and so we caught it, and so we dealt with that fact. So in summary, in this, we talked about if statements, we talked about else, we talked about try and accept, how important indentation is to mark blocks where they begin and the end, and an else if, and try accept. So up next, we're going to talk about loops and iteration.
All right. Yeah, so it feels like, what comes to mind when thinking about the try and accept stuff is when you're dealing with users and you're trying to prevent, it's really what he's, as I'm thinking about it, like he said pretty much this exact thing, where he mentioned like if a traceback happened on his grading thing, That would look bad on him. And so, like, when dealing with, see, like, I don't know what situations would call for try and accept usage if we're not dealing with someone else dealing with the code, if that makes sense. Because if it's just us dealing with it, why would we need to? I don't know. I guess we'll see as time goes on. Given the following code, temp equals 5 degrees, Celsius equals 0, var equals float temp, Celsius equals var minus 32, then multiplied by 5, divided by 9. So I remember the answer to this one. I actually took a photo of this the first time I went through it and talked with my dad about it. And he kind of explained it a bit. I can't remember what he said. But the answer is 3 or 4. 5 degrees. Because they're trying to turn temperature into a float. Which is could potentially problematic. You know, with the whole degrees thing. And then Celsius equals Fahrenheit. Take away 32. Okay. That's still a little confusing to me. But we'll move on. No exercises on this one. This is good. How long is this? Okay, not crazy. So let's just get into our exercises then. And we'll see what we got.
Hello everyone, and welcome to Python for Everybody. I'm Charles Severance. I'm the instructor for the class, and right now I want to go do exercise 3.1. Rewrite the pay computation that we did earlier in the previous chapter and give the employee 1.5 times the hourly rate.
Is this still up here? I really don't want to mess. Guys, hold on. Whoops. That's the streams. It was 3. Oh no. I didn't save it right. Can I just Control Z? Hold, please. All right, yes.
This is rather simple. It's a very classic computer problem because it gives us our if then else, and there's a lot of different ways to write it. So we're just going to do enter the hours, enter the rate, and do the pay. And so I'm going to start by going into my terminal.
Okay, can we just, we're going to try this right off the rip. So we got, so that's defined. We just let those be. And we can leave these, right? Because that just turns them into integers. So if I'm freezing up here. Hours. Output hours is greater than 40. Rate times, can I just do 0.5? Or is it like 1.5? Technically, I don't know what. Oh, and we need to have like an error, like an error clause. Okay. Let's kind of bump this down. Let's make the error thing. Or maybe should the error thing be up here? If input hours can I say does not equal int? Frick. I'm scared. Print. Please enter number. And then wait. Because I won't even need an wait. Okay. Brain meats, man. Just doing it. So we got them entering the hours. We got them entering the rate. If the hours does not equal I feel like it should be a try. I just don't know what to put for it. Try. I don't know. Let's try the int thing. Because then if so if hours does not equal int, so then I also need if my r does not equal int, then we can just copy and paste. Can we just try this? Whoops. Okay, so we're in here. Can you all see thereabouts? Okay. 10. Nope. Oh, let's do this. Hold on, hold on. I think I got it. Try. And we'll pump this up into that. And then accept. Oops. We'll go print. Please enter number. Now let's try it. The heck, man. Does it need to be multiple tries? Try turning OH. Expected fail. There is an accept. I'm gonna move this. Can I just drag it? Ooh, that's cool. Try. How about this? Accept. Okay. Line 3. It's the equals. Try. What about this? Try turning IH into an int. I feel like we're getting close. Eight? Wait, 8? Well, let's just leave you out of the equation for now. Whoops. Okay. Please. No. Wait a minute. Wait. It worked. Kind of. It has to be broken up. Because I put in this, and I put in this, and then it, please enter number. Okay. So let's. Okay, input, enter hours. Try making that a number. So right off the rip, if I put this, it works, man. Oh. Whoa. That's okay. Okay, I'm not too stressed about that right now. Okay, let's try and move on. So this will, this is good, right? So we're doing this, right? Comment. Everything above works. Okay, now we're going to do enter rate. Do the same thing. Excuse me, except for this, we're going to do IR. Except please enter number, and just for my own my own sake, we're going to do this. There we go. Okay. So now it should work for both hours and rate. Hours. Whoopsies. Hold on. Sorry. Please enter number. What? If OH is greater than... Oh, that all... Okay, let's just... We'll forget that for a moment. Whoops, I did it again. 10. Please enter number 10. What? Should be an elif. Wait. Try. Okay, so this is all just contained then. It's not telling... It's not... Because we got the hours. Wait. What? Oh, it works now. What? Wait. Whoa. Oh, I'm like making bugs. Oh, man. So if it doesn't work once... Oh, man. I want to stick through this. I think I'm making it more complicated than it needs to be. Worst case scenario, we'll just follow what he does, but I'm trying to think. Okay, let's just kind of... Okay. How... Because right now, and hey, it has it where they enter hours and then rate one right after the other. My brain. Maybe we should just set this to the side for now. Let's worry about the overtime thing. If hours is greater than 40, if overtime out or if output hours is greater than 40, then overtime out. Wait. Overtime output rate equals output rate times 1.5. Right? What was the, it was if, elif, else, print, output rate. Where's the times output hours? Oh, pay I should like that, right? So we'll just assume that those are numbers up there for now. Enter hours, enter rate, turns into integers. If hours is greater than 40, then out or overtime output rate equals output rate times 1.5. Wait. Yeah, no, that's right. Else, basically meaning if it's not over 40, print pay basic hours by rate. So then we just got to do print pay oh shoot, pay's not defined as anything. If so we got to define this. If output hours is greater than 40, I'm not doing that right. No, I might. It might work. I don't know. Okay. So this is print pay, and then I can just do overtime output hours times, or rate, excuse me, by hours. No, that's not right. Should be plus 40. Print yeah, because he's not getting overtime rate for the whole 40 like plus hours. It's just what it's over 40. Whew. If output hours is over 40, output overtime rate equals this might work. What if we did, okay, output overtime rate times minus 40. That might work. Oh, please don't blow up. No. What line? 11? What? The whole deal? Is it the space? Whoopsies. Print. It's not closed. Okay, so that works. What do you mean I forgot to go? Okay. Okay, we're in business. We're in business. Whoops, I already messed up. Okay. Wait. $13. Wait. So if overtime is over, or if hours is over 40, well, else should have run, right? Oh no. Okay, no, this shouldn't be here. It should just be your basic. So that's good now. This, if it's overtime, wait. Overtime equals. Here we go. Print. Pay. Rate. Times. Hours. Minus 40. Whoops. Oh my gosh. Let's try this. Oh my gosh. Why did it print it twice? Oh. Right. Okay, so I don't need this. Do I? I don't need that either. Oops. Okay. Moment of truth. We'll go 50. What would be easy? 10. What's time and a half? What's... The problem is I don't know if that's right. What's 50 times 10? Wait a minute. Wait. So that was 10. Because I did minus 40. So 50 minus 40 is 10 times 1.5 is 15 times 10 hours. It's 150. Which works. Oh my gosh. So we're about to actually get the like half of what we need. So that's like the overtime. So if output overtime rate, or if overtime, goodness, if output hours is over 40, so let's just try something ridiculous. Whoops. So that's like the base pay, right? And then plus over, so it's going to figure out the base pay. Which would be like, let's say we use 50 again, right? Times 10. It's 500. Yes, I use a calculator. Plus the overtime output rate times the hours minus 40. So let's say it's 50, which minus 40 is 10, obviously, times the rate, which is 1.5. Whoops. Does the 1.5 matter? Can I just do 0.5? We'll leave it at 1.5. I don't know if that's actually accurate, but we'll just assume it is for now. Print equals the base pay plus overtime so it's going to calculate this first. Whoops, let me just get this. Is going to complicate things. It's going to calculate this first. It's going to calculate this, which would be 10. Because then it's, you got 10 hours of overtime. And that's 1.5. Wait, that can't. So if you have 10 hours of overtime, and the rate is so it needs to be output overtime rate oh my head. Come on, man. I'm so close, bro. I feel like this is the hardest part of the day. I mean, I say that. I don't know what the next exercise is. Pay. So the base pay is fine. And the else is fine too. So anything under 40 hours is fine. We just need to figure out the stinking overtime. So what even is the overtime? So if you have 10 hours of overtime, what do you have to do? Whoops. So it's like $15 an hour. But that's not enough. Because right now that just calculates how many hours of overtime there are. And this is the 10, so that calculates the 15, so like 15. Actually, no, hold on, could that work? Overtime. So that's the base hours times 1.5, which is 15. So if it's over 40, it'll print the base pay plus the overtime. Oh my gosh, this could work. Oh my word. Okay, so hold on, let's figure out what this should be. We'll do 40 hours at first, so 40 hours. Okay, that works. Now, so that's like the base pay, 400. If we do 50 hours, 10 is overtime. So 10 times 15, which is 150 plus 400, so that's 550. Oh, I want this to work, man. Oh, 50 hours. What? Wait. What even happened? Invalid literal? What just happened? Enter hours? Okay, wait. What just happened? Why did I get that trace back just then? Oh, okay. Now we got 10 again, right? I'm all scared. What did I do before? Yeah. 650. Can I just not do math? I feel like it did it right. I feel like I just can't do math. 40, 10, 400. What? Why is it 250 more? Well, so let me calculate this here. So the base rate is 400 plus so this right here is 400. And then the rate is going to be, whoa, 15. It's right here. That's going to be 10. So 15 times 10 plus. Okay, should be 550. Why? Why is it 650? Let's try this. We'll just do something to test. 41. 425. Okay, that didn't really help. Oh my gosh. So 15. Rate times 0.5. I don't know how it's getting this number, yo. I don't know. So the rate will always be like 15. Overtime rate. Output rate times output hours. Oh my gosh, I think I figured it out. I figured it out. It's right here. It's right here. This is where it lies. Print. Is there a way around that though? Because this is giving us the base. This is it's really right here. Oh man, what if? I'm going for the dub. Okay. Wait. If overtime's over. Wait. The rate times 40. Oh my gosh. Dude. 550. Move this up here. Sorry, you guys haven't been seeing it the whole time. I'm sorry. Okay. Oh. We did it. Oh my gosh, we did it. Oh. And I'll tell you guys, this is not how he does it in the video. It's totally different than what we did before. Oh my gosh. It freaking works, man. So we need to be able to, we have to be able to fit in like a try except without just ruining everything, right? Excuse me. Oh. That's like the best feeling, man. This is coming from a guy who doesn't really know what he's doing. Okay. So as of now, what? So that's weird. Wait. So it's line full. Okay. So let's try this then. Oh, my stomach hurts, man. I don't want to hurt anything. Can we just exercise for working overtime? Okay, so we can't mess up OH or the OR. If we did this. Try it. Else. Print. Please enter a number. Is it accept? Okay. No. Where is it? 7. Please enter number. So I don't know. We'll try this too. Is this just a horrible idea? I should grab that as well. I mean, I'm glad we can even get this far. What? Something's getting caught up. Something's getting caught up. Try. I want to try something. Whoa. We still going? Okay, we're still going. I heard a beeping. Did you hear that? I don't know. We're going to get rid of the tries. We're going to go with ifs. If. IH. Is. Is that greater than or equal to? Zero? Should be like -1, right? Accept. What? What should it be? It is accept. Did I spell it wrong? No? Except. Just try. It should be an else. Oh my gosh. Not support the instances between string and integer. Oh, it needs to be turned into an. Oh, okay. We're learning. So this doesn't work because it's an this is an integer and it doesn't know it's an integer. I don't think. I think that's the problem. I just want to try something, man. I don't know if this will work. Type int. Equals. Really? Wait. Oh, now we're into here. Okay. Do number 4 hours. So we'll just do the same thing. Except for the rate. Okay. What happened? Oh. Oh. If. So I don't need this here, do I? No, I don't. What? It was, though. OH is not defined. What do you mean? If IH equals type. I don't know if this is even a thing. I'll be honest. Let's just watch what he does, man.
CD into my desktop.
Jeepers.
CD Python for
My
everybody.
brain.
And so here we go. Let me go into
half an hour doing
and
that.
get things started. I've already got this folder, this file from the last one, assignment 2.3, and I'm just going to save as. So I'm going to duplicate this file, and I am going to go up to PY4E, and then I'm going to make a new folder. I'm going to call that folder EX0301 for exercise 3.1, and then I'm going to call this EX0301.py. Now that's just the same files I had before, and if I do an ls, you'll see I've got the new folder. So I cd into the EX0301 folder. So that's the folder that I'm in, all the way down into this folder, and I do an ls and I see this file, and so life is good. And I can say Python 3 EX0301py. I'll just put in 1010, so it's 100. Now, the thing is that we're supposed to give time and a half for overtime. And so that means if there's more than 40 hours, 10 and 50, it's not supposed to be 500. It's supposed to be 500 plus half of 10 extra hours, because the 10 extra hours are the 10 above 50. So that should be, I don't know, we'll figure it out. It's easier to run a computer. Okay, so this is the code we've got. So,
So I don't know that
is change this.
I don't think he's going to get into the error. Like, please put in a number. I don't think he's going to get into that in this one, which is fine. We can just watch this.
I'm going to make a new variable called AR. I'll call it FR, stands for floating point rate. And floating point rate is going to be the float of the string rate. Let me just call this SH for string hours and SR for string rate and SR. So this stands for, my variable is FR for floating point rate, just so I can keep them straight in my head. SH is string hours, and so now I'm going to say floating point hours is equal to float.
So he's turning them into numbers like we did.
String hours.
We turn them into integers, not
Now I
floats.
can change this, so I just am saying FH times FR. So I split this out. I can even like print FH comma FR. It's perfectly fine when you're writing this to add like, extra print statements just for your own sanity. So now we're going to read the two values. We're going to convert them to floating point numbers. We're going to print those floating point numbers out. We're going to multiply them, and then we're going to have the pays. And then I save it. Always remember to save it.
So this
Right,
is
so it
base
has a
pay.
little dot up here. All editors give you something that tells you you didn't save it, and so I always keep saving it, because if you come down here and you run it and it's like it didn't change. Well, that's because you forgot. So let's do our 10 and 50 hours. So we see this extra print statement that came out. That's that extra print statement right there. Let me make this a little smaller, and let's move this over here so we can see it a little better. Yeah, make it a little bigger so we can see a little better. So that print statement's there, and just for yucks, I'm going to comment that out. And so
that's not base pay. What he did was just multiply the hours times the rate.
commenting things out is a good way to keep stuff in that you might want to kind of turn back on. It's a way of thinking about it. I don't want this line to run, but I'm just keeping it here. Comments are usually for users to read, but they're also a way to tell the computer to ignore what we're doing. So, okay, so the problem here is this calculation. That is not time and a half for overtime. So, so the way we're going to solve this is with an if statement. If the floating point hours, FR, is greater than 40, we should, I'll say print overtime, and then else, colon, the if and the else have to line up, print regular. So I'm not going to do anything different. I'm just going to print the words regular and overtime. Okay? And I just save that.
So he's really
I'll
taking
do
it
so fast.
slow.
You watch the little blue dot happen and then go away. That's because I hit Command S to save it, because I've done this way too many times. So I'm going to run it. I'm going to say, hours is 10 hours, $10 an hour. It's regular pay. If I do it this way, I can do 50 hours at $10 an hour. That's not good. What did I do wrong? FR is greater than 40. What did I do wrong? It's still saying for 50 hours. Something's wrong here. It's saying it's regular. If FR is greater than... Oh!
I don't know what it
Because I
did.
just messed my program up. So look, I called this variable SH and this SR, and then I get the floating point for the hours, but look, I'm checking if the rate, FR, that's the mistake.
Oh, it should be the hours.
So it's really, I've got
Hours
to
are
look
over
for
40.
FH. That's a logic error. It's a perfectly fine program. Python's perfectly
Wait, what?
happy with that. And I was messing up. I kept putting, I was typing the...
He didn't fix it.
Rate in, I thought, so I was just typing it backwards. I was crazy.
This needs to
And
be the
again,
hours.
that can be the kind of mistake that you run into. I mean, I didn't do that on purpose. I did it because I haven't drank enough coffee yet this morning. Hang on, let me get some coffee. I have more coffee. I'm still going to make mistakes. So now, there's no little blue dot, so it should work better now. Python, run
I
it.
know that it will.
So 10 hours, $10 is regular pay. Run it. 50 hours, $10. I did it wrong again. I told you what I wanted to change, and then I didn't change it. FH. I'm like crazy. Again, you can be crazy too. Can you look right at it? I looked right at it. I did the wrong thing. Hooray! It says overtime. And now you notice, I mean, I'm not being silly here where I put this print statement in, and it's so tempting for a programmer to just immediately try to bam, finish it. And I don't know why I did it this way. Maybe because I know that I'm flawed, and I know that I make dumb mistakes like that. And what can I do? So I was just being really careful there. Now I know, let's just be sure, if it's under 40 hours, it's going to be a regular computation. And I'm going to leave these print statements right in here for a while because whatever. So here's the interesting thing. So I'm just going to indent this because the regular pay is to take the number of the hours times the rate, okay? And now I got to come up with a slightly different pay. XP is equal to, and so there's a couple ways to do this. We can say time and a half can be calculated by saying the rate times the hours. Well, let's do it this way. Let's call it regular. The regular pay is the rate times the hours. FR times FH. And then the overtime pay is equal to the... Now we know that we have more than 40 hours because we couldn't do this in here. So if I say
Regular minus 40?
Number of hours that you've worked, FH minus 40.0, that is the number of hours above 40. So if this is 50, then the FH minus 40 is going to be 10. And then I'm going to multiply that times the rate, FR, except you get 1.5 times, right? So your overtime pay is the excess hours times 1.5 times the rate. Actually, no. I see I made a mistake already. The extra overtime pay, because you're going to get all your regular pay, so the 50% or the half is the extra. And see, I'm confused, so I'm just going to print out reg, comma, OTP. And if those numbers are
ours
right,
still works,
I can do
so.
XP, which is the pay, is equal to
physically
reg
works.
plus OTP. See, my program is always I have to make it a little smaller. Let's make it so you can see the whole thing, right? So I think I got this right. Right? I figured out the regular hours, which is giving you the base rate for all 50 hours or 45 hours or whatever, figuring out the excess hours, and this is the bonus amount. There's lots of different ways that you can calculate this. But in general, we have an if statement on this side,
Like if we put
and
1.5,
this else is the easy one, and that's
result.
40 hours or less. So if we're doing greater than 40. So I just hit Command S to save it. And so let me clear my screen with Command K. So I'm going to do 10 hours at $10 an hour, and that's a regular calculation, and it's $100. And so if I do 50 hours at $10 an hour, so my regular pay was 50 times 10, and then the excess pay is $5 an hour times the extra 10 hours, which is $50, and so my pay is $550. And so it looks.
Hold up. Oops. Let's get rid of all that. Hey, whoa. Now I'm confused because we got the same answer but just differently, but we used a different percentage. Because we did 0.5. Because this is the overtime. The rate times 1.5. Which is accurate, right? I think we still did it right. Like ours still works. Because you make $10 an hour. You work over 40 hours. You work another hour. You work like you work like 1 hour over 40. You'll make 15. That's time and a half. So ours still works.
It's like I've got this calculation right. And so
so he did. It's like 41 takeaway. That'd be like 1 in our example. Times the rate. That was 0.5. Because we basically did. Yeah, this is the exact same thing as this. times, and we just did this, but over here. So this is the rate times 40. So this gives us the bit. This is assuming that you work 40, over 40. Output rate times 40. So that's like 400 plus output rate is 10 times, wait, this is 10 times 1.5, which is 15. Wait a minute. So this will always be 15. So 15. Yeah, because if you work over 40 hours, like I said, your time will be bumped like time and a half, which is like 15. And then this is this calculates anything over 40, because say it's like 45, take away 40, you have 5 hours of overtime. So then you multiply that by the overtime rate, which is 15. It makes logical sense. I just don't understand why his gives the same answer. I'm going to take a picture of this. I'm going to talk to my dad about this. Because ours is right. Ours is right. So if it's over 40, hours, take away 40, which again, what we have, like there's like 5 times it's like 10 times 0.5. I think that's where it comes into it right there. Right here. Because this calculates the base. Because that calculates the whole thing. Like, you work 41 hours. Yeah, because that, yes, that's what, okay, good. So, this rate, you multiply that by the whole, like, 41 hours. So that's included in here. So he's just kind of thinking about it a different way than we are. But so you get like the whole, like your base $10 an hour for like 41 hours. But then he's just kind of leaving out that fact that you're getting like the base one for the overtime. I like our way better.
Here's the thing. I have been putting these extra print statements in. It's a real common thing for a programmer, and you can look on GitHub and see code that I write, and I just leave these in because, you know, that could be broken. But you're not supposed to print this extra stuff out. And if you do this in the auto grader, it's going to complain about these extra things. It's going to consider you broken. And again, so I comment those out to do one final test. And notice the little blue dot, so I have to save it. And now I can run it one more time. And I do 10 hours, $10. And it prints out exactly what I want to see and not the extra stuff because I commented them out. And I do 50 hours and $10 an hour is $550. So I've got it right, and at that point, you should be able to go back and go to your auto grader if this was in the auto grader and paste the stuff in.
Oh, my word.
So I hope this exercise 3.1 was useful, and thanks for watching.
Jeepers. Oh. Oh, I feel like I need a breather from that. Man, that was like a long dang time. This is probably where we'll get into the error one. I just want to get this one done, everybody. I'll be honest with you. Let's do it.
And Python for everybody. I'm Charles Severance, your instructor. And in this short video, we're going to do exercise 3.2, which is really just a rewrite of exercise 3.1. We're going to deal with some error conditions using try and except. So let's go ahead and get started, but this is a good example of something where you want to start with the previous assignment. So let's open the file that I did before, and so this happens to be right here, EX0301, and there's my previous program that I wrote for exercise 3.1. And let me set myself up with Python so I can actually run it. CD desktop.
I might just watch
desktop, CD
him do this because we tried so long.
Get better. CD
and we messed around with tries
301
and accepts
ls, and I can say Python 3 ex0301.py, and you know it works fine if you give it the right data, but if you give it bad data, 10 and ten, it blows up, right? And like always, you're getting trace specs for all kinds of things, but this one's pretty clear. If you slowly but surely don't get mad, just say, oh, line 4. What could be wrong in line 4? Could not convert string to float 10. So what it's complaining about is on line 4, this variable sr, which is the string ten, the letters ten, is not working. So this function is blowing up. Okay? So that's what it's complaining about. And that's what we want to deal with. Now when you're using try and except, you don't want to just put a try, you want to limit how much data that you put in the try and except, or how much code you put in the try and except. So let's get started on assignment 3.2. So the nice thing that we can do here is we can say File, Save As, and go up a folder to PY for everybody. Make a new folder called EX0302, and then save the file as EX0302.py. Okay, so now make sure, get rid of that. So make sure this is different. We're in a different folder, so we're not editing that old file. And the first thing I'm going to do is, come on. Well, I'm get rid of some of these statements. I mean, the code's going to work. Come on. Okay, so the dangerous line of code is right here. And so the problem becomes, how are we going to deal with this? And, so let me do this as well. So here's if I do pwd, I'm in EX0301. This could drive you crazy. Oh wait, I'm in the wrong folder. How come this is in the wrong folder?
I'll be honest, I don't even want to mess
EX0301
with command prompt.
Oh, why is this in?
Like I was like, oh yeah, we'll mess with this for a bit, but we won't forever. It's like that did not last long. I apologize.
I think I'm in the
It's
wrong
just easier
folder.
to do it in
File,
Visual
open.
Studio.
EX0302.
So it's gonna be easy. We're already 3 minutes in. He's
Okay, so now I'm in the right spot.
okay.
I don't know why that wasn't showing up right, but keep your eye on this, especially when you're using
This is gonna be
file names that are
like oh, I should have thought of this.
so So I'm in this EX0301, so I'm going to use a command, and you can use this both in Windows and in Linux and in Mac, cd ... And what that does is that goes up a folder. Part of the goal of this course is to teach you how to use things like this, just how to use these command lines, because to be a programmer, even doing the simplest stuff, you got to manipulate files, and you got to be able to use command line, you got to use all these.
Okay, I want to see if that actually works. Oh, wow. Cool. It does work.
These things.
I mean, because he's on a Mac, obviously, and we're not on a Mac. So I was just seeing if that actually work on PC. It does.
Not everything is a full screen clickety-pointedy thing, okay? And so what does CD do? Well, it looks at this and it goes up one folder. So it moved us up into here. And so you can see after the CD, my current working directory is that, and I can do ls to see the folders. And now I see my new EX0302. So say CD EX0302. And part of being a programmer is having a lot of folders with weird names to organize your stuff, ls. And so here we go. Now we have this file and this file in the same place, pwd. This matches this, that file matches this name, and I can say Python 3 ex0302.py 1010. Okay, so now I'm just nervous enough to want to double check this, and so I will do something like this. I will say XYZ pay and save it, and then run it again. Python 3, I don't care about the numbers. See the XYZ pay? So now I know I'm in that file. So I do stuff like this all the time to triple check that I'm really working with the file. So now I'm in this file, and now let me make my mistake again, 10, 10, and now there's my failure, right? So there's the mistake, and that's the thing we got to fix. So we have these lines of code. So what you do in Python, when you know that there's a dangerous set of lines and you want to take out insurance on those, you put them in a try-catch block.
Both of them?
Try-except block. And what are we supposed to say when it blows up? It says, error, please.
Whoops. Here we go. Print. Error. Please enter a number. Dude, we spent so much time on this fan. Can you see? Okay, we're right down here. Let's clear this. Ten. Traceback. Oh no. So we got the error. Now let's just see what he does.
Please enter numeric input. I'll just copy that and paste this. Print error, please enter numeric
Break.
input. Make that a little bit wider. Print that out.
Wait.
And I want to put this print statement back in. Okay. So here we go. So now what's going to happen is we're going to come in here. We're going to run these. If they work, we'll skip the except block and continue. If they blow up, then it's going to run this except block. So let's run it. Let's start with a working case. That still works. That's good. It comes and does this extra print that I've got on line 9. Let's go in the bad case.
We haven't covered breaks yet, so I don't
10.
think that's it. So you got to trace back to good.
Okay, so we got to parse this a little bit. So it says error, please enter numeric input, but then I still get a trace back. And you're like, I hate computers because doesn't this look beautiful? I got to try, indent it, it looks just like what I saw, right? It's so beautiful. Why does this computer hate me so badly? Well, then take a step back and say, you know what? The computer is admitting that it's confused by what you've given it. And So just look, what line are you mad about, dear computer? Line 9. Okay, let's take a look at line 9.
13.
It's always this line or the one before it, almost always. Almost always it gets it right. And it says name FR is not defined. So that, just focus on this. It's complaining about this. And the problem is that it came down here, it ran through here, ran through here, and this blew up. That line never ran. That's the line that blew up, and then
because the
error. So it never got a variable or a value in FR.
Because in our situation, OR is not defined, so that's the one that, yeah.
And that's because
same situation.
In this particular case, we would either have to put an if statement in to make sure the rest of this code, or we can say, you know, if everything is just so bad in this thing and I don't want to continue,
I forgot about
quit.
this.
Basically
Break.
says
That's
do
what I
not
meant.
continue. Okay?
Like break, we'll learn about breaks later on with loops and stuff. But quit's like the same thing.
So when it comes in here, it runs this, it
Oh,
blows
say
up,
less,
it comes
that'll
down
work.
to here, it prints this, and then it quits. And then it doesn't continue on. So now I can run this again. 10, 10.
Okay, so once again, we will clear. Oh my word. 10, 10. Awesome. Heck yeah. Okay, let's try the top one. Oops. Why'd that take?
And it works. 10 and TEN, and it fails exactly the same way. This part here is exactly the same as this part here. The difference was, as soon as we print this out, we quit so we don't continue on. Okay? So if you're doing really simple sort of input checking, sanity checking is one of the things we call this. We're just, is the data make sense? And don't continue. If the data doesn't make sense, if these two statements don't work, then whatever we've been given is nonsensical data that we're not capable of handling. Okay? So that is how to write exercise 3.2. And
I think I know how to
hope
answer
that
the
you have
question.
found this little video useful, and thanks for watching.
Okay. So let's try this, right? Break it up. We'll put an except for this. And then we will do another try for the other one. Hours 45 10. Let's do 50 just so I know it's right. Should have done that before. Okay. Now 10. Please enter number. And then what? Because it tried my inputted. try. Oh. Oh, please work. Oh, please work. Oh, please work. Okay. Here we go. Hold your breath. Whoops. Oh, I'm scared. Doesn't even matter. Okay. Moment of truth. Oh. Oh, we did it. Oh, I didn't go about things this way the first time I was going through this, man. Oh, this feels good. This feels good. This feels like I can actually, like, do it. You know what I'm saying? Like, do the... Like, I can actually learn. Oh. 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 Oh, man. Save that mess. Save. Working with errors. Error. Working gives errors. I don't know how best to say this, but we're doing it. We're saving that. Oh my gosh. I think we might be done writing code for a while because we just have to watch. We're watching the video. We're answering this. Then we're getting into that playlist. Let's do it.
So welcome back. Let's talk a little bit more about some more complex conditional statements that sort of build on this concept of if and if then else. The first thing we're going to look at is the multi-way branch.
Did we do this? Yes, we did. Yes, we did. Because it's 3 and 4.
Conservative. We do this conversion, and that's the dangerous part. And in this one, it's going to blow up.
Yep. Okay. Oh, I think we can kind of relax a little bit. Oh, my goodness. Crazy. I'm going to get a drink. Hold on. Oh, my gosh. I need to play some video games after this. Oh, goodness. Video games or... I don't know. Something.
Hello and welcome to Chapter 4, Functions. This is the fourth of our basic patterns. We'll get to iterations next. Functions is the store and reuse. One of the things in programming is that we never like to repeat ourselves. We don't like to, if we have 4 or 5 lines of code and we're going to do the same thing later, we don't like to put the same 4 lines of code in, even if it has to do with reliability. If you find something wrong with those 4 lines of code and you got them 12 different places in your program, then you got to find all 12 places and fix them. So like collect those to one place and then call them and reuse them, and that's the idea of store and reuse. So this is how functions work inside of Python. The first thing we notice is there is a new keyword def that stands for define function. And the def is like an if statement, or we'll see fors and whiles, that they end in a colon, and then they have an indented block, and then the indented block de-indents, and that's the end of the function. And so there's 2 statements make up this function. The key thing that you have to
understand and get used to is this def part is actually not running any code whatsoever. It's actually remembering the code. And that's what I call the store phase. The def creates a bit of code and records it like a macro, although it's much more complex than a macro. And it names it whatever you chose. You gave it a name. We named this one thing. And so it, as a side effect of Python reading or parsing these 3 lines, it doesn't do anything, but it remembers. These 2 lines are what you would like to run when you invoke thing. So this is the definition of a function, and this is the invoking of the function. But so this doesn't do anything. So there's no output here from that stuff right there. But then what happens is you invoke it. And this thing looks like it's part of Python, but you in effect have extended Python with your def statement. And so when it sees thing, it goes up and runs your code. And so out comes hello fun. And then it comes back and goes to the next line, does print, so print comes out. And then it goes back and like, oh, this is the reuse part, but we get to reuse it. We define it once and we use it twice. Then it runs this code again and then goes to the next line and it's all done. So this little bit came out twice. And of course, this is really simple so that I can fit it on a page, but you get the idea that I don't want to repeat. This might be, 15 to 100 lines of code, and I don't want to type those over and over again. So I say, hey, store these in a name that I choose, and then when I invoke them, bring them back and then run them again. Okay? So that's the basic idea. We actually have already been using functions from the beginning. The print is a function, right? Print is a function. Every time we see print, P-R-I-N-T, parenthesis, and then we have some stuff in here, we're calling the print function. This is the syntax with 2 little parentheses, is the syntax.
I need to tape up my vent really quick. It's cold in here, and my wife and I like it chilly in the nighttime. But when I'm up, it gets cold, and so I'm gonna tape it up. I did before, but then it came undone. So 1 second, bear with me. Okay, that should hold. That should hold. Let us continue.
X for functions. And so input's a function, type is a function, float's a function, int's a function. All these things are built-in functions that come with Python at the moment that we started. I mean, we installed Python and these came along. And then there's other functions that we define and use, and that's what the def is for. And in effect, we can create new reserved words of our own making that extend the Python language after we define the function. So it's just this bit of reusable code that takes some arguments. We haven't seen any with arguments. There's a little parenthesis, and we'll see how that works in a bit. We define using the def keyword, and then we invoke it. There's the defining phase, which actually doesn't run the code, it just remembers the code, and then there's the invoking phase. You define it once and then invoke it 1 or more times. Calling the function or invoking the function, we think of those 2 things as the same thing. Call, invoke are just the terms we use. Most people just say call the function, but invoking it is a perhaps more descriptive way to think about it. So here's an example of a function. It is built into Python. It's called the max function. And we can pass some parameters into the max function. So we pass the hello world string. Now, like much of Python, max knows it's what kind of thing is being passed into it, and it knows that it's looking for the largest character, the lexicographically largest character, and in this case, it scans this little, that's inside the max code, it scans through and finds the largest character. So apparently, lowercase letters are higher than uppercase letters because in English, we get back a W. And so this is what's called the return value. So this is an assignment statement. Let me clear this and start over. So this is an assignment statement, so it has to evaluate this right-hand side, and a function call is nothing more than like x plus 1. It's something to evaluate. It runs the function code, passes in this argument, and then this residual value, this is called the return value, we'll look at this in more detail, becomes the result of this little bit in the expression, and there's nothing else. We could have, w plus.
What's he saying about arguments?
Clear this and start. Finds the some parameters into the max function. So we pass. So here's an example of a function. It is built into Python. It's called the max function. And we can pass some parameters into the max function. So we pass the hello world string. Now, like much of Python, max knows it's what kind of thing is being passed into it, and it knows that it's looking for the largest character, the lexicographically largest character, and in this case, it scans this little, that's inside the max code, it scans through and finds the largest character. So apparently, lowercase letters are higher than uppercase letters because in English, we get back a W. And so this is what's called the return value. So this is an assignment statement. Let me clear this and start over. So this is an assignment statement, so it has to evaluate this right-hand side, and a function call is nothing more than like x plus 1. It's something to evaluate. It runs the function code, passes in this argument, and then this residual value, this is called the return value, we'll look at this in more detail, becomes the result of this little bit in the expression, and there's nothing else. We could have, w plus 1 or something, and then the w is what's stored into big. Okay, so we print big, and big is a variable that has the letter W inside of it. And then we ask what is the smallest, and that finds the blank, and so we get a blank to see this. There's a min function and a max function. Both of these are built in. These are built-in functions. They're always there for us. Okay, so here is another example of the max function, and so we can think of this as invoking or calling this function as this right-hand side is being evaluated. We are passing this variable in, and there's some code in here, and it's going to do some stuff, yada, 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 and then it's going to give us back a bit of stuff, and that's its return value, and then that goes up into the big, right? And so that's how this works. And so this is actually built in or burnt in, I guess I can't draw. And so you can think of this as sometime a long time ago when Python was being first formed, somebody wrote some code. And it's got some stuff in it. It's got a little loop that reads through all the letters. It has to figure out if it's a string or a list, etc., etc., etc. But this is store, except you didn't do the storing because it's already built in. And then this is the reuse, store and reuse. So we build these things into Python. They're already pre-built, as if before the first line of your code executes, way up here, someone put all this code in for you into Python and created a thing called max for you. Now we've been using this already, built-in functions, we've got type conversions, we've got like the float that takes a integer and returns a floating point version of that. And again, this is kind of like an expression. So it's like, I want to divide this by 100, but before I do that, I've got to convert it to a float. So it has to sort of do...
This is what I was mentioning the other day, where it said when you, when I was talking about floats and integers, when you put an integer and floating point in an expression, the integer is implicitly converted to a float.
These function calls as it's evaluating the expression, okay? Sometimes, like here, we just have a prints out the return value. That's what this is. This is the return value. If you just type a function in a parameter, It can be in a constant or it can be a variable, and as we'll see in a second, we'll give you many of these if you like. So you can either just run it or take the result of this. This passes an integer in, converts it to a float, and then puts the float into that. Type tells us what kind of thing that is, and you can use this inside of an expression. And so it's like, what am I going to do first? Oh, I've got to do 2 times this thing. Oh, wait a sec. Pause just briefly for a moment to call out to some float code. Pass a 3 into it, and then
it makes it a 3.0.
and something comes back, the return value, the residual value comes back, and then that participates. In this case, it's going to be 3.0, participates in this 2 times 3.0. Okay? And so 2 times 3.0 then ends up being 6.0, et cetera, et cetera. But you can see as it's like, oh, wait a sec, I got to figure out what this is, call the function, get the return value, and then continue processing this expression. We've also done this with string conversions, partly because, just as an example, the input always returns a string. The input function returns a string. And so, here's this string, could be coming from input, but we'll just take 1, 2, 3. We know that that's a string. It's not the number 123. And if we try to add 1 to it, we get a trace back. Cannot concatenate string and integer. Trace back. But we can't convert that string to an integer. And so int can take like a floating point number or an integer or even a string, and it says, oh, I know what I'm supposed to do with a string. I'm supposed to look at this, interpret these as numbers, and multiply by 10 and figure out what the hundreds place is and all that stuff. There's a little bit of work to that, and it does it. But then it gives us back an integer, and we say, oh, what is that? That's now the 123, but it is of type int. And
I'm just trying to understand. So 1, 2, 3. So that turns 1, 2, 3 into an integer. So 1, 2, 3 plus 1, 2, 4. This is L can't do it because there's no. Okay.
And now we can add 1 to it and get 124. And as before, from this example that we're kind of reusing from a previous chapter, you don't want to try to convert, oops, sad face, sad face. Sad face. Don't want to try to convert something that doesn't have digits using int, because it'll say, I don't know what to do, and then your program quits, right? You don't want your program to stop, tracebacks, and you can, of course, deal with that with try and accept, but that's like a previous lecture. Okay, so up next we're going to talk about building our own functions, not just using the predefined ones.
What is the purpose of the def keyword in Python? It indicates the start of the function. It indicates that the following indented goes to be stored for later. I use that one. It indicates the start of the function. The following indented section of the code is to be stored. Wait. I use that one actually. I could be wrong. Hey, did it. Did it. That makes sense though. The this here. Can you guys see? So like this is basically, it's saying that svol is 1, 2, 3, and it tries to basically add 1 to svol, but right now it's like understanding svol as a string, which you can't add a 1 to, so then it has to turn it into, you have to turn it into an integer in order to, which this is just saying like what type of it, or what type is ivol after we made it an integer, and it basically just says it's an integer. Add a 1 to that, which is 1, 2, 3 up here, because svol, 1, 2, 4, and then this is basically just saying you can't turn only letters into an integer. So Hyper combo finish. Only one exercise. We're getting into the part where I remember, like I just did this not too long ago, so we're getting up into the part where I was. But let's there we go. Let's I don't want to spend too much time. It's getting kind of late for me here. And we've already been going for close to 3 hours, but I want to just bring this up. And we'll see what we can see. If it watch it just be like the longest playlist ever. Oh, wow, this is pretty long. Oh, my word. It's 145 videos? Wow, dude. We'll just kind of... kind of breeze through some of these. We'll just kind of see what's up.
Hey there, how's it going, everybody? In this series of videos, we'll be going over the basics of Python programming. Now, and within our terminal, we can say Python -- version. Now, we can see here that the default Python is Python 2.7.
6 years ago.
Now, it used to be more controversial as to which version you want to use, but almost everyone is moving over to Python 3. And if you're learning Python, then you're definitely going to want to go with Python 3 unless you have a really good reason to do otherwise. So let's go ahead and install the latest version of Python 3.
Okay, good.
So to do this, we're just going to pull up an internet browser, and we're going to go to the Python
So homie's in
alias.
Python 3
now,
too.
to do this, all we have to do is say alias Python equals
I like this guy
Python
though.
3. And you want to make sure it looks exactly like this. No space between the equals or anything like that. So now to save this, we can just hit Control X to close, hit Y to say that we want to save it, and then hit Enter to keep that same file name. So now if we quit out of our terminal and open this back up, and now let's check that Python version again. So I'm going to do Python -- version, and now we can see that it's using Python 3.6. Now, I probably should have mentioned this earlier, but you do not have to create that Python alias. If you wanted to, you could just use that Python 3 command to run all of your scripts. But I like to use this Python command, so that's why I personally like to create the alias. Okay, so now let's walk through how we install Python 3 for Windows.
I'm not going to mess with that right now.
Come
The
down here
alias thing.
to our active prompt, and we can see that it shows that we're using Python 3.6. Now, the interactive prompt allows us to write one line of Python at a time. So, for example, for a Hello World application, then we could simply write print hello world. And we can see that it prints that out. And we can also set variables. So I could say x is equal to 10. And if I print out x, then we can see that we get 10.
Dude.
Now, this interactive prompt is okay for testing Python commands, but we really want to have a
My
Python
vent.
file where we can write multiple lines and run an entire script. So let's exit this interactive prompt, and we can do that by typing exit and then opening close parentheses. So to create a Python file, we're going to need some kind of plain text editor. When we downloaded Python, it came with an editor called idle prompt where we can write one line at a time. Hello world. Now we're going to want to save this file, so we can save this by terminal or our command. So if we're in our home folder program. Now I still have this Python file up over here, and real quick, let me show you how to do a single inline comment in Python. If I wanted to write, I'm going to go ahead and write a comment. You can see that it didn't do anything to our script. It's still just running the script from the command line. Atom. So if you want to use either of those editors, then I highly recommend Python file and execute that script. So in the next video, we'll start learning about variables and data types, and specifically in Windows, one of the files, or we could here in using one of these editors is that you can run Python from directly within the editor. So I have the same intro.py file that we just created pulled up here in Sublime.
Okay. I like this guy.
My name is Kate. I'm an artist.
Didn't think about that being copyrighted.
On everybody. In this video, we'll be learning about Python data types, and specifically we'll be learning about how to work with textual data. And textual data in Python are represented with strings. So we currently have open our intro.py file that we were working with in the last video, where we just printed out hello world. And I'll go ahead and run this so that we can see that down here it does print out hello world. Now, this line here is using the print function, and we're passing this text value into that print function. Now, if we wanted to create a variable that holds that text value, then we could say, now I'll just get rid of this comment for now. So if I wanted a variable to hold that value, then I can just create a variable, and we'll call that message, and we'll set that message variable equal to our text value that we passed in to print. And here, message is our variable name. So if you're coming from another language, then you might be wondering if we need to use semicolons or something like that to end each line, but Python doesn't need that. It operates on white space alone, which makes it a very clean language to work with. Now, by convention, our variables are usually all lowercase, and if it's multiple words, then we separate those with underscore. So if instead my variable name was my message, then it would be my underscore message. So that's just a convention that's commonly used. And also, these variable names should be as descriptive as possible as to what values they're meant to hold. So message is a good variable name here because it's holding our message. But if I was instead to call this variable m, which is a valid variable name, but anyone reading my code now wouldn't know when they see this m variable what value it's supposed to hold.
This dude's
so
good
message
at
is a much
teaching.
better variable name in this case. So this message variable now holds our text data, and our text data is called a string. Now, we can use our variable in place of this string anywhere that we use it in our program. So instead of printing out hello world directly here, I'm instead going to now print out this variable. And that should give us the same results. So if I run that, then you can see down here we still get the same result. Now we can see that I created this string with single quotes. Now you can also use double quotes. So if you're wondering if there's a difference between the single quotes and the double quotes, then it really just depends on what text you have in your string. So for example, if you have a single quote in your string, so for example, let's create one with a single quote. Instead of hello world, I will instead make our string Bobby's world. Now see, the problem here is that Python sees this single quote within our text as being the end of the string, and it's not going to know what to do with what comes after that single quote here, because it thinks that's where the string is closing. So if you run this now, then
I got a little distracted. I'm trying to see. Should I like move this? Oh no! Hold on. Let's grab the whole thing. There we go. Let's move me out of the way.
quote in your string. So for example, let's create one with a single quote. Instead of hello world, I will instead make our string Bobby's world. Now see, the problem here is that Python sees this single quote within our text as being the end of the string, and it's not going to know what to do with what comes after that single quote here, because it thinks that's where the string is closing. So if you run this now, then you'll get an error. Now there's a couple of different ways to handle this. We could escape this single quote with a backslash. So if I escape that single quote and now run this, now Python knows that this single quote doesn't close out the string, and that instead this one should. Now another way to handle that is to instead, so I'll take away that escape character. Now another way to handle that is to instead just use double quotes on the outside of our string, any string that contains single quotes.
I like
so if we know that our string contains a single quote, then we can instead use double quotes on the outside, and then it'll know that that single quote isn't the end of the string. So now if we run this, then we can see that it still works fine. But that doesn't necessarily mean that double quotes are better, because it goes both ways. If your string contains double quotes in the message, then I would use single quotes on the outside. Now if we needed to create a multi-line string, then one way we can do this is by using 3 quotes at the beginning and end of our string. And these can also be single or double quotes as well. So let's go ahead and look at an example. So I'll add 3 quotes to the beginning and end of our string here. And now I'll just add some text to span some multiple lines here. So I'll just say, was a good, and then hit enter to go to a new line, and say cartoon in the 1990s. So now if we run that, then we can see that it printed out our string correctly over multiple lines. Okay, so let's go back to our simple hello world example. So I'm just going to take all of that and replace it with our previous hello world example. And now let's go ahead and just run that really quick. So we're back to our starting point. So we can think of our string as a string of individual characters, and we can access these individual characters also. So first, let's see how we can find how many characters are in our string. So to do this, we can use the len function, which stands for length. So whenever I print out here, if I was, instead of printing my message, if I was to print out this length function and pass in message, and then
Let's just try and do something with him. I like this guy. We're probably going to be doing more with him. No.
and run this, now we're no longer printing out our message, we're printing out the length of our message. And we
Oh, very cool.
can see that it says that the length of our string is 11. And if we counted these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then we can see that that's correct. And we can access our string's characters individually. So to do this, we can use the square brackets after our string and pass in the location of the character that we want. So I'll say print message and then square brackets. Now the location is called an index, and it starts out at 0. So to access the first character of our string, we can say print the message and then access this index of 0. So if we print that, then we can see that we got the capital H. Now, since the length of our string is 11, that means that with the first character starting out at 0, our last character would be at index 10. So it's our total length minus 1. So if I was to say print out the location at index 10, the value at index 10, then we can see that we got our D character, which is the last character in that string. Now, if you accidentally try to access an index that doesn't exist, then you'll get an index error. So if we were to say access the index of 11, then we can see that that threw an index error. Now, we can also access a range of characters. So if I just wanted to get the word hello from our string, then we could say that we want accidentally try to access an index that doesn't exist, then you'll get an index error. So if we were to say access the index of 11, then we can see that that threw an index error. Now we can also access a range of characters. So if I just wanted to get the word hello from our string, then we could say that we want 0 and then this :5, and we'll explain this. So the first index here is our starting point, and the second index, which is separated by this colon, is the stopping point. Now, one thing a little confusing about this is that the first index is inclusive, which means it's going to include that value, but the second index is not. Now, there's good reasons for this, but it's still easy to forget. So basically what we're saying is I want all the characters between the beginning and up to but not including the 5th index. And it'll be more clear if we just go ahead and run this. So we can see that it prints out hello. So it printed out our message from the 0 index here all the way up to but not including the 5th index here. So we got hello. Now, since our starting point here is just the first index, we can actually just leave that off, and it'll assume that we want to start at the beginning. So if we don't put anything there and then :5, then we should get the same thing. So if we run that, we can see we still got hello. Now, instead, if we wanted to grab the word world from this string, then we could start at the 6th index And then we can just go to the end. And just like leaving off our starting index, it will start from the beginning. Leaving off the stop index just goes all the way to the end. So now if we run that, then we can see that it gives us back the word world. Now what we're doing here is called slicing. And if you'd like to learn more about slicing in depth, then you can watch my detailed video on that, and I'll leave a link to that in the description section below. So now let's just go back to printing out our message, and let me run this. Okay, so all of the data types that we're going to review are going to have certain methods available to us that give us access to a lot of useful functionality. Now, when I say methods, a lot of people wonder what's the difference between a method and a function. And functions and methods are basically the same thing. A method is just a function.
Sorry, I just hear one of my computers running. It always makes me nervous when I hear things. I'm like, is it dying? Nothing's beeping or anything, so I'm hoping it's okay. It just where I don't usually think about it. I don't usually think about the sound it makes. When I do notice it, I'm like, ooh, something wrong. Should be okay. I hope it's okay.
That belongs to an object. It's not important to get into the details of that now, but if you hear me say method or function, then you can basically think of those as the same thing for now. So like I was saying, the data types that we'll be going over all have methods available to more about slicing in depth, then you can watch my detailed video on that, and I'll leave a link to that in the description section below. So now let's just go back to printing out our message, and let me run this. Okay, so all of the data types.
It just got way more quiet. That's weird. I don't know.
Types that we're going to review are going to have certain methods available to us that give us access to a lot of useful functionality. Now, when I say methods, a lot of people wonder what's the difference between a method and a function. And functions and methods are basically the same thing. A method is just a function that belongs to an object. It's not important to get into the details of that now, but if you hear me say method or function, then you can basically think of those as the same thing for now. So like I was saying, the data types that we'll be going over all have certain methods available to us that give us access to a lot of useful functionality. So let's look at some of these string methods. So we can see here that our hello world text is capitalized. But let's say that we wanted that to be all lowercase. Now to do this, it's just as easy as saying print message, and then to lowercase this, we can say dot lower. Now when we run this dot lower with these parentheses here, that's running the lower method on the string. So when we ran that, we can see that now our hello world has been set to all lowercase. And if we wanted to do this to uppercase, then it's as easy as changing that lower to upper. If we run that, now we can see that hello world is all uppercase. So now let's say that we want to count a certain number of characters in our string. And to do that, we can use the count method. And the count method actually takes a string as an argument. So we can say message.count, and now we have to pass in an argument. And it has to know what we want to count in our message. So for now, we'll just say count hello. And if we run that, we can see that it returns that the string hello appears in our message one time. But if we instead just passed in a single character as our argument, so I'll pass in an L, if I run that, you can see that we get a 3 because there are 3 L's in our message variable. So if we instead want to find the index of where certain characters can be found, then we can use the find method. So I could come up here, instead of saying .count, I can say .find, And now this takes an argument as well.
It's going to be our
It's
last
what we
video.
want to find. So let me type in world here and run this. And we can see when we run this that it returns a 6. And that's because world starts at the 6th index of our message variable. Now, if we try to find a string of characters that doesn't exist, then it will just return -1. So if instead of world, I typed in universe and ran that, you can see it returns a -1 because it can't find that anywhere in our message variable. Okay, so now let's say that we want to replace some characters in our string with some other characters. And we can do this with the replace method. Now, first, I'm going to change this back to printing out our regular message. So I'll just delete these. Now let's try to use our replace method right below where we first set our message variable. And this method takes 2 arguments. First, it takes what we want to replace. So first, let me just say message.replace. So first it takes what we want to replace. So let's say that we want to replace world. And now the second argument, which is separated by a comma, is what we want to replace world with. So we'll replace world with universe. So
That's
now if
helpful.
we run this, then this might be a little unexpected. We can see that it's still printing out hello world. Now the reason our replacement didn't work is because it's not making that replacement in place. It's actually returning a new string with those values replaced. And we'll learn more about return statements when we learn about functions. But basically, we need to set a new variable here to get that returned string with those replacements. So I could say something like new message is equal to that original method with
Print new
this
message.
replacement. So now if we set that new variable and instead print that new message and run that, then you can see that now it replaced world with universe. And if you really wanted to make the replacement to the message variable, then instead of making a new message variable, then we can just set this same message variable again. So now we're setting the same message variable equal to that replacement and then printing it out. So if I run that, then we can see that now the message variable had world replaced with universe. And this may look a little strange to set a variable to an altered version of itself, but it's very common and you'll be using that a lot. Okay, so now let's get rid of this replace line here. And now let's look at how we can add multiple strings and concatenate them together. So instead of saying hello world, I'm instead just going to set this equal to hello. And instead of calling this message, I'm going to set this equal to greeting. And just below greeting, I'm going to create a variable called name. And I'm going to set that equal to, we'll just say Michael. And now lastly, let's create a message here. And we want this message to combine our greeting with our name. We want it to say, hello, Michael. And one way to do this is to use the plus sign operator. So we could try this by saying greeting plus name. Now, if we run this, then we can see that it's not exactly what we wanted. It combined them together, but it doesn't have a space there. So when you're concatenating strings together, it's easy to make mistakes like this. So what we want to do is add a string between them that spaces them out. So we can add a string between these just by putting in a string literal here. And I'm also going to put in a comma and a space to separate those. And now we also need another plus sign so that we're adding the name after that string. So now we're saying that we want this greeting, which is hello, plus this comma and space, plus the name. So if I run this, then we can see that it concatenated those strings together how we wanted. Now, sometimes using the plus sign isn't the best way to go. If we wanted to create a longer, more complicated string while using our variables, then adding them all together like this might get hard to keep track of. So let's say that we wanted to add to the end of our message just by closing off a sentence and saying welcome. So to do that, after our name variable, we could add another string that is a period to close off that sentence, a space, and then welcome with an exclamation point. So let's go ahead and run that. Now we can see that it printed out the string how we wanted it to look, but it's starting to get a little complicated on this line here to keep track of all of our plus signs and spaces within our message. Instead, with strings like this, it's usually better to use a formatted string. This allows us to write the sentence as it will appear and put placeholders in place of our variables. So let's go ahead and see what this would look like. So to instead use a formatted string, we can say message is equal to, and we're just going to write it exactly how it appears, except everywhere where we want to replace with a variable, we're going to put in a placeholder, and those placeholders are going to be these curly brackets. So we want a placeholder for the greeting, and then a comma, a space, then a placeholder for the name, then a period, and then we'll type out welcome and an exclamation point. And now to fill those placeholders with our variables, we can say dot format and pass in greeting for the first placeholder and then name for the second placeholder. So now let's go ahead and delete this line where we were using the plus sign operator. So if we run this, we can see that we got the same thing as when we concatenated them together. But with longer, more complicated strings, this is actually a little bit easier to read. It might look a little confusing now since we're just seeing these placeholders for the first time, but after you get used to this, you will realize that this is easier than keeping track of all those concatenations. And using string formatting like this also gives us some extra functionality, and if you want to see everything that you can do with that, then I do have a detailed, in-depth video on string formatting, and I'll add that to the description section below. Okay, and lastly, if you're using Python 3.6 or above, then you'll have access to these new things called F strings. Now, if you aren't using 3.6 or higher, then these aren't going to work because they were only recently released. And not a lot of people are using these F strings yet, but I'm really liking them so far. Basically, the idea behind F strings was to make string formatting as simple as possible. So let's go ahead and see what these look like. So to say that we want this to be an F string, we can just add an F right here to the beginning on the outside of the string. Now, instead of using this dot format method, we'll instead just write the variables directly within the placeholders. So I can remove that dot format method, and now we can pass the variables directly within the placeholder. So we'll pass greeting to that placeholder and name to that one. So I can save that and run it. And you can see that using that, we got the same result. And like I said, these F strings are pretty new to the language, so even people who are very familiar with Python may be seeing this for the first time. Now, one reason I really like these F strings is because you can actually write code within the placeholder. So if I wanted the name in all caps for some reason, then I could just come into the placeholder here and say name.upper and run that directly within the placeholder. If I run that, then you can see that now our name was capitalized. Okay, so we're almost finished up, but I wanted to show you one last trick here when you're learning something new in Python. So we saw a lot of different methods that we could use on our strings. Now, if we ever wanted to see everything that's available to us, then there are a couple of things that we can do. So first, we can use this dir function, and that looks like this. And what this does is if we pass in a variable, then it will show us all of the attributes and methods that we have access to with that variable. Now, don't worry about all of these double underscore methods yet, but if we look down here, then we'll see a couple of familiar methods that we used in this video. So, for example, we have .upper here, we have .replace, .lower. So this kind of gives you a broad overview of all the attributes and methods that are available to you. Now, this doesn't show what any of these actually do. So to see more information about these string methods, then we can use the help function. But if we run this help function on the name, then that won't work. We actually need to run it on the string class itself. So we'll just type in help and then str for string. And if I run that, then we can see that this gives us a lot more information. And I'll pull this up here a bit. So it tells us everything that's available to us, and if I scroll down here a bit, and if I try to find something that we actually used in this video, okay, so we have find here. So you can see that it actually gives us a description of what these methods do and what arguments they take. Now, if you know that you had a certain method available to you, but you couldn't remember exactly what it does, then you can actually pass it directly into help also. So if I wanted to find out some more information about the lower method, then we could say string.lower, and if we run that, then we can see that it gives us information and the description just of what lower does. So using that dir function and that help function is a great way to get a broad overview of the methods and attributes that are available to you, and also what using the help function gives you an idea of what those methods do without actually, going online and checking everything there. Okay, so I think that is going to do it for this video. I hope that now you feel comfortable with working with strings and are familiar with some of the useful things that we can do with those. In the next video, we'll be learning how to work with numbers in Python, and specifically integers and floats. But if anyone has any questions about what we covered in this video, then feel free to ask in the comment section below, and I'll do my best to answer those. If you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up, and also it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.
Okay. Wow. So that's that. That's the Yeah, make sure to check out Corey. Support his stuff. We will continue to use some of his content. I want to use it sparingly because homie knows what he's talking about, which is not a bad thing, but I just don't want to, excuse me, I don't want to flood my brain with all of the stuff he has to offer. Yeah. So we'll continue to, tomorrow we'll do the next 3. I like this one because it feels more digestible. Like he, while very good, and I want to continue to use his, use his stuff. It's a lot. It's a lot. I want to know why. That's the thing. He gives you all these things you can do, but I'm like, why would I want to do that? Why would I want to make everything uppercase? I don't know. But, whoops. There we go. Man, one heck of a stream today. Almost 3.5 hours. Whew. Did some good coding on our end. Trial and error, figuring some stuff out. That's the good stuff. That's where the learning is. But thank you guys so much for watching. Please make sure, if you have a prayer request, please feel free to put it in the comments below. You don't need to if you don't want to. Yeah, so please make sure to leave a prayer request. If you don't have one, you don't need to worry about it. But I'd love to be able to pray for you guys if you do have one. Leave a like and subscribe if you want to. And I think that's going to do it for this stream. So thank you guys so much for watching. And I will see you guys tomorrow.